which is based in London. And so I was talking about how we can use Kaggle to improve our data science skills and also machine learning skills. Yeah. So we're going to cover a bit about what you can use Kaggle for, what are the ins and outs and the little tips inside which you might want to use over the coming weeks, as well as how Kaggle can integrate with some cloud technologies. And we're going to top it off with a live demo how we can do this, right? So at any time, if you have any sort of questions, feel free to pop it in the chat. I'll probably go through the chat towards the end, but at any time, please feel free to just pop in the questions, right? Yeah, so just a quick poll about the group. Yeah, I was quite curious I was wondering where is everyone from, and maybe you could sort of just pop in the chat sort of where you're currently based at, or whether you are in the States or you're in London. Like, it would be great just to know where's everyone from. And while you're doing that, just a quick introduction about the Meetup group that is in London. And if you're in London, we have a few community leads running this, and we try to have events regularly. We try to have more face-to-face ones this year. So if you're around London, feel free to join up in the Meetup group to meet myself or Anandita or Christina. And of course, Bill would be in the States, but you would see his support on online side as well. All right. Okay, just looking through the chat. All right. So Zurich, Oslo, awesome. Lots of people from London, Paris, and Austin. Thank you so much for joining today. So again, Bill has probably already done an excellent introduction to AI Camp. We'll jump straight into what is Kaggle. So I like this quite interesting way of someone put it as the Airbnb for data scientists, and why one of the prominent Kagglers said this is because that's where data scientists spend their day and night, and when they're off to Kaggle. So that's why. But in a more serious note, Kaggle was initially a small group that started in Melbourne, and it started in the year 2010 as a small community of machine learning practitioners and data scientists. However, in 2017, it grew to about 1 million users, and that really sort of caught the attention of quite prominent people. And a few of them would be like Varian from Google, and also Max Levchin. And yeah, because these guys saw the potential where everyone's getting together and really discussing about data science and really working on real life problems in one place. So Kaggle actually was bought over by Google, and it's now officially Google product. Yeah. So if you're sort of new to data science in general, and even if you haven't had any experience with Python at all, I would really recommend that you start off here at Kaggle. So if you go to this kaggle.com/learn, there's really a whole suite of micro courses which are free, and it's a really nice way to sort of introduce yourself to what's Python, what are Jupyter notebooks, what are really the tools that data scientists use. And yeah, if I just do a quick sort of live demo now, I've got it open here. So if you go to the Python lesson and course, you see that within just Python itself, we have about 7 lectures covering Python, and each sort of course comes with a tutorial notebook that you can read through with explanation, as well as an exercise that you would do. So if we just have a quick look at how it looks like, if you open up one of the tutorials or exercise, it opens up a Jupyter notebook. And if you are not familiar with what Jupyter notebooks are, they are a really nice environment where you can explore code and run codes in sort of cell blocks. And for the purposes of data science, data visualization, data exploration, I find the use of Jupyter notebooks, it's really useful, it's really intuitive to use. So for example, you can see that these blocks, they only run, Jupyter Notebooks runs their code in blocks. And if you want to execute the code within that block, it's quite easy to do so. You sort of just press this button and basically there you have run some Python code. So that's what I really like about Kaggle. I started out with zero knowledge about Python and programming, but I think Kaggle is a way to sort of it's a really accessible way to get into this, learning this and being familiar with it, right? So after you completed any of the courses, and make sure you complete all the exercises as well, you do get a certificate that you can put on your LinkedIn if you wanted to. And this will come from Cago as well, right? So far, besides the courses, oh, sorry, Vikas was saying that you can't see my screen. Is anyone else having some problems with screens at the moment? Okay, Bill says we are good, all good. All good, all right. Maybe try login again, Vikas, if that helps. Sometimes if you restart, it just pops back and it works again. Okay, so right now, Kaggle, there's sort of active competitions going on all the time. And we'll sort of get into more of that. It's what I like about Kaggle as well. Currently, there are over 200,000 notebooks being published on Kaggle, and a lot of them are public notebooks, which are a really useful way to look at how other machine learning practitioners write their code, what is the industry standard, and it's really fun that way. As well as you get a lot of access and free access to tons of data sets. So when I checked the numbers yesterday, that's 29,366 different types of data sets on Kaggle. And we'll go through that in a bit. We did cover the micro courses already, and there are some job boards as well on Kaggle. Okay. So far, there are about 4 million models that's been submitted to all different types of competitions. And that it's a really active community where you can see about 4,000 posts on forums a month. So what is the point of participating in this? Just let me give you some interesting history. So at one point of time, Geoffrey Hinton, he's a Kaggler as well. And if you're not aware of him, he is one of the recipients of the Turing Award for excellence and contribution in the field of AI and machine learning this recently. So he was one of the first few guys who actually won a Kaggle competition where he used a deep neural network for a pharmaceutical company's competition. I wouldn't tell you which company or or when was that, but yeah, that would be interesting. And if you really like to find out, you can look through the data about competitions and use some data science skills to find that out. Um, an interesting note also is that one of the famous algorithms that we use now, XGBoost, was also debuted on Kaggle, and that's where it was first introduced, and people found that, hey, it's something really useful, it's efficient, and it's kind of one of the mainstream ones now. So a lot of these competitions are, in fact, how can I put it? They are not just for sort of monetary gain, but the competitions are an opportunity for you to sort of work in real life problems with huge companies. So historically, a lot of the knowledge of from Kaggle has been contributed and used in HIV research, and also for the discovery of the Higgs boson in the CERN. So yeah, it's really cool. And right now, these are the active competitions that are going on at the moment. The top one would be probably most outstanding at the moment. So the deepfake detection challenge is a challenge that's put up by all the large tech companies, so Microsoft, Facebook, Google, and they're offering sort of 1 million award for the best team that can identify a deep fake video. I think, yeah, again, besides the monetary value, it's sort of the opportunity to contribute to the knowledge of machine learning, data science in another way. And also, yeah, it is an actual problem which is affecting the machine learning community now, and identifying deep fakes, it's quite tricky. So if you like to know more about this topic, or really interact with people who are actively working on deepfake detection, you can always just join in the competition, go onto the forums, look at what people are posting, and there are some incredibly smart people on Kaggle. But then again, there are always other competitions that you can join into, and it's not limited to just video detection. We have sort of image recognition, as well as some time series competitions as well. If you can see the NCAA one would be a time series sort of competition. So one of the recent ones that just completed I found was quite interesting was this, which is the 3D object detection for autonomous driving. So this one was really cool, where Lyft actually sort of, they open up their framework, and as well they offered up quite a big data set for people to go through, so you get access to sort of really cool data that you wouldn't get anywhere else. So LiDAR data, 3D sort of camera images. And if I just open up this as a quick live demo, if you go to the competitions, you get to see what other people are doing as well. That's what I really like. So if you haven't dealt with 3D data before, I think this is a really cool place to have a look at it. And someone has written a really nice notebook about ingesting 3D data, and you can sort of look at the code, and he's sort of visualized it quite nicely here. If I just scroll it around. So yeah, that's sort of what LiDAR data work looks like and how it's used to detect sort of the vehicles around. That's really cool stuff. Yeah. For myself, my personal interest is within how machine learning can be used in the healthcare field. So this is really my passion, and I have personal experience with joining this competition, which is a competition to sort of image classifying competition, basically to determine the severity of brain bleeding from medical scans. So my personal experience with this was really fun because this is where I learned how to ingest big data from medical imaging, and the data set from this one competition alone is about 160 gigs of medical DICOM data and CT images of the brain. So what I've learned just by participating with this, looking at what other people are doing, I've learned how to plot DICOM data with matplotlib. Also Kaggle's API, where you can sort of link Kaggle data sets with other cloud providers. And this is where I used a Google Cloud and their sort of storage and machine learning AI platform to sort of ingest all this data. So this is a really, really fun one that I did recently. And if you look through sort of the notebooks, what other people have done as well. So it's sort of really state of the art, and where people are using different models such as ResNext from Facebook, which is a residual deep learning network for image classifying. Some people tried it on Google's CNN, which is Inception V3, and even some people trying VGG from Oxford on this data set. So it's quite interesting. And one thing to note is there is a leaderboard for each competition. You can really use that to judge what is your performance of your personal model, how accurate it is compared to others. And you can see at the end of the competition what is how others have done their models and how they have sort of tweaked or fine-tuned or used a different parameter that was better in this task specifically. Yeah. Yeah. So aside from the micro courses, I think competitions are one of the ways which you can use to push yourself to learn more machine learning while working on interesting but challenging projects. And while you're in any of these competitions, the forums are really a gem where you can interact with expert and real world expert data scientists. And these are not toy problems, but they are real life problems from companies. Yep. Okay. Sorry, someone was mentioning that there's an issue with the connection. The voice is being cut off. Is that all right now or no? Let me know in the chat. Okay. Chris says it's fine here. All right. All right. Getting it's not a problem. Okay, so we should continue then. So this is just one of examples of a Kaggle hero where this guy, Abhishek, he is the world's first 4 times grandmaster in Cago, and it's quite interesting to see that this guy who's fully self-taught in machine learning, uh, with no background basically in this field, but achieving this level of practice and knowledge in machine learning is quite unparalleled. Though I wouldn't say that it was solely from Kaggle that he got this far, though this was his quote about being on there. He said that it generated an unquenched curiosity to learn more and to do more research and sophisticated research in the world of machine learning. Yeah, so if you're on the forums, get to sort of see what the opinions of, really smart people like this. Okay, so we move on to sort of covering the data sets. And even if you feel like competitions are really not my thing, not so competitive, that's all right. We on Kaggle as well, you get access to lots and lots of data sets. So as of now, I've just checked that there are 29,421 data sets on Kaggle, and just data from various domains. So financial data, crypto data, data about social science. And if you wanted to do some analysis on the coronavirus as well, some health data, there are people sort of posting this on Kaggle and it's all public domain. So it's a really nice way to look for projects. Really, you have no short of what projects that you want to do. And awesome thing is that the work that you do on here can be shared with other people, and it lets you sort of counter check your work with other machine learning practitioners as well. Yeah, so there are really some fun data sets. I remember one guy who posted a data set just on smartphone images. So he took pictures of his smartphone in various angles, sliding down on the side in various environments, and he posted that whole data set on Kaggle as well. So if you're doing sort of an app where you wanna do object detection and you want to detect everyday objects, so it's a really nice way to sort of look for places to complement your data set as well. Okay. Okay. Yeah, so we did cover a bit about the Jupyter notebooks and environment. So in Kaggle, there are 2 types of ways that you can code. And one of it is the notebooks, which we kind of saw a bit earlier. There's also another type, which is scripts. And scripts are basically sort of what they are like. If you are familiar with Linux sort of sh scripts or Windows bat scripts, so basically these are sort of bunch of codes that you can plug into other notebooks. So for example, if you have written a certain pipeline or a certain way of reorganizing text, for example, or ingesting text, you can store it as a script and then use that in your Kaggle notebooks as well. And what are these notebooks? Basically, they are an environment or a Docker environment where all the Python libraries that are usually used are already handpicked for you and installed, basically. So you don't need to go through the trouble of loading your own Anaconda environment and worrying about conflicts between this version of this package and that version of that library, because the Kaggle team takes care of this for you, and they have a team of people to constantly look at and update to the latest frameworks, and making sure that these updates do not break other libraries and whatnot. And yeah, it can be quite tricky to sort of say you want to incorporate a package that uses your GPU. However, you don't need to worry about this if you're using Kaggle Notebooks, when the GPU integration has already been taken care of by the Kaggle team. So I really like this about the environment. And yeah, towards the end of our webinar, I'll show you guys live how you do this. It's really, really simple, okay? And recently, this year as well, I've got this really exciting news where TPUs are now available on Kaggle. So yeah, if you see on the second paragraph where say TPUs are powerful hardware accelerators that good in deep learning, it's really quite exciting. And what a TPU is really, it is a Google device that stands for Tensor Processing Unit. And what it is it's really specialized and efficient in running deep learning sort of training. And I think one of the breakthroughs in deep learning that happened recently is because people learn to harness the power of training deep learning networks on GPUs. And if you can see here that just by using GPUs alone, there is 15-fold to 70-fold of increase in the speed of training your models. And what's quite interesting as well is that if you opt to use TPUs for certain models and deep learning models, you can see a further tenfold sort of improvement in the efficiency and speed of training of your deep neural nets. So I think this is really awesome. And if you wanted to be sort of, in tune with what's the latest hardware being used and what are the latest things that people are using in the machine learning and data science field, the awesome things is you can try out and use TPUs, but on your own code, on Kaggle Notebooks as well. So yeah, we're gonna try this in the demo right after we get to the end of this presentation. Yep. And yeah, this is what a TPU kind of looks like. It's quite unassuming, and basically it's a bunch of chips that are put together. I think the interesting point to note here is that each TPU, and the one that is available for use on Kaggle, is a TPU version 3. So the big advantage that a TPU has versus a GPU is that one TPU gives you access to 128 gigabytes of RAM, and a typical GPU, I think it's about 8 to 16 gigabytes of RAM. So especially if you're doing sort of deep learning on image classifying tasks, so for example, like the medical images, that is really quite a big sort of bottleneck there, where the GPU can probably only contain 4 to 8 sort of images in one batch, and that kind of slows down the whole training process. So with a larger RAM allocation, you can really push through a lot more data to your model. So you can also have larger models if you wanted to. And that's really the advantage of having a TPU. Yeah. Okay. So we're going to jump in straight into the live demo. I have it here. So this is a notebook on Kaggle, and it is also publicly available. So if you wanted to, after the webinar, to have a look at the code, or use the code and try it on your own as well, you're very welcome to do so. So what we're gonna do quickly, maybe in about 15 minutes, is to sort of do an image classifying model. So we're gonna train an image classifying model using transfer learning. And the model that we're gonna use is MobileNet, which is a model from Google. We're gonna train this on the TPUs that are available in Kaggle. And what we're gonna ask the model to do is to basically classify types of flowers. Yeah. Okay. So I've opened this up on a Kaggle notebook. And if you wanted to basically turn on TPUs or GPUs, it's really easy. There's a sidebar here on the Kaggle notebooks, and down here under accelerator is where you want to go to. So if we just pop that open, you see that you have two options. You can either go use the GPUs or TPUs in this case. There is a restriction, however, on the use of these. So every week, each person has about 30 hours of GPU time to be used up. So a quota in that sense, as well as 30 hours of TPU time as well. So in total, 60 hours really, which is really, I would say if you're starting out in deep learning, it's more than enough to sort of learn or play around with. Okay, so we're gonna use TPU in this example. I'll just turn it on here. And okay, so here you go. Okay, yeah. While it's loading, if you guys have any sort of questions, feel free to pop it in the chat. Okay, so we're not going to go into the sort of nitty-gritty of the code today. I don't think we have the time for that. If we wanted to sort of go through line by line, maybe you can have another session on one of these if you guys need that. All right. So first off, we're gonna import the usual libraries and TensorFlow. So just to note that currently only TensorFlow 2.1 works with TPU, so you can't use the older frameworks on it. Okay. Oh yeah, so Omti has shared the link on the chat as well. Thank you for that. So yeah, feel free to sort of go on that, and you can follow on. Or you can always just look at the live demo. Okay. So this code is just to change the training strategy or distribution strategy of TensorFlow to distribute the work over the 8 cores on the TPUs, right? And then what this code does is we're gonna load the Kaggle data sets onto Google Cloud Store. And this is basically the training parameters that we're gonna use. So just quick note here, since we are borrowing the MobileNet V2 model, what we're really doing is we're doing transfer learning. So initially, MobileNet was trained to classify, I think, thousands of different types of objects, so dogs, cats, and flowers and whatnot. And so all the weights of these models is already being preset by Google. What we're gonna do today is just fine tune some of these weights to do a specific task, which is to classify 5 different types of flowers. And a good sort of how can I put it? A kind of industry standard on how we do this is we set a sort of learning rate schedule where we start with a really low sort of learning rate and slowly ramp it up over the epochs. So if you start off with a really high learning rate, that might change the weights on the models too much and actually negatively impact the accuracy of a model. So this is what this code basically does, to slowly increase the learning rate over, I've just arbitrarily set it at 5 epochs here, and then slowly decrease the learning rate after that. So we can't increase the learning rate indefinitely, because again, that would sort of negatively impact on the accuracy of the model. So when we expect that the model performance has reached a plateau, it's a good idea to sort of taper down your learning rate with the idea of using that to fine tune and make sure that the weights of your model is being changed at a smaller rate. So this is in hopes to improve accuracy better, right? So we're gonna just skim through this part, and this is this code to sort of plot or use matplotlib to show the images of the flowers later on. Right. Okay. So here we're gonna set our training and validation data set, and using the functions above basically show us what are the types of images we're dealing with. So we have, again, 5 different types of flowers in the data set, and that's what we're gonna train our model on and use it to detect and predict on later. All right. So on this block here, we're gonna create, do transfer learning on MobileNet V2, and you see here we can include a parameter which is to include top equals false, and basically we're removing the last output layer of MobileNet V2, and we're replacing it using Keras with basically 5 outputs that we wanted. Yeah, and that's what it's gonna do. Oh. Okay, so we've just downloaded the model from GitHub, and this is the original MobileNet V2 model. And you can see here with the model.summary function, we sort of tag on our own final layer, which is with output shape of 5 basically. So 5 different clusters. All right. And we're gonna start off the training right now. So this will take maybe a couple minutes, though you can see that it won't take too long because we're gonna run it on TPUs. So the image size that we run on here is about, I think it's 300 times 300 pixels. And if you do this on the GPU, it take actually much longer. Yeah, so while this runs, I'm free to sort of take any questions if you guys have, or if you guys wanted to know anything, can feel free to pop it in the chat. Okay, while that runs, just let me scroll up a little bit. Okay, yeah, so here, when you're doing sort of image classifier training on deep neural nets, it's quite important to set the batch size and basically how many images that you want to put into a batch to be loaded onto your GPU or TPU at one point in time. And really, this is what the bottleneck alludes to, what we were talking about, where the amount of RAM that you have on your GPU really limits how much data you can put onto for training at one point in time. So with a typical GPU, you can probably get away with putting 16 images at one batch, though with a TPU, you can multiply that by about 8 times. So really, this is one way where you can overcome the bottlenecks in training deep nets. Okay, yeah, so some questions. Leon Moore is asking, have you seen many use cases for anomaly detection in Cago? Okay, yeah, so there was a specific one which I remember, which was a credit card fraud detection, if that makes sense. So looking through financial data and transactional data and really picking out from the millions and millions of transactions which sort of transaction is a potential fraud. So for example, if a user is in London and his credit card is being used in, I don't know, in Asia, for example. So that would be flagged out, and based on the timing and the amount, that would be flagged out as an anomaly and flagged as a fraud. So that is one of the examples which I remember offhand. Though, to be fully honest, a lot of times, most of the competitions are time series, or there's a lot of computer vision competitions. Then if you really wanted to have a look at more about anomaly detection, I think you need to go into the data sets to look through and see what other people have done. But that's the one that I remember. And okay, so Yan Yan is asking, any strategy for a number of epochs? Is the larger the better? Okay, yeah, so we'll sort of plot this and have a look at how this one works out. Okay, so the training is done. And this is basically the loss over time and how our model performs. So it's really a balance between sort of the number of epochs and the learning rate. So it doesn't mean that if you have a lot of epochs that would make your model really accurate. So if you can see here, if we continue training, our accuracy on a new data set or data that the model has never seen might get worse. Yeah, and why this is happening is because the model might be overfitting on the training data set. So it's sort of becoming too focused and too specialized on the training images. When the model is presented with data from that's never seen before, it can't generalize as well. So really, I think there is no set number of epochs that you can use. It's really sort of fine tuning between and sort of trying out and seeing what works best for your use case and your model, right? So as you can see at the end of our training, the accuracy that can achieve is about 75%. And you can use our model to do some predictions. Okay. So using a function that we wrote earlier, you can see that the mobile net that's now being fine-tuned is able to sort of pick out a few types of flowers. So it's labeled tulips here, sunflowers, dandelion, roses. So pretty accurate, I would say. Though it's 75%, I think for our use case of sort of shifting through and determining what types of flowers in these 5 groups of flowers, it's pretty accurate actually. And as you can see, it's pretty fast as well. Yeah, so I think that we have come to the end of the live demo. I hope you all enjoy, and if you have any question, we have about maybe 10-15 minutes to sort of run through any sort of Q&A and whatnot. Okay, so just some credits to the code and notebook. This was sort of provided by Martin Gorner, who is a Google he's a developer and one who is working as developer relations in Google. So I've sort of put out this code for us to really learn how to use TPUs. Yeah. But it is on public domain, so feel free to sort of shift around and use it on other models if you wanted to. Okay. Yeah, so that's all from me. If you wanted to know more about our group, can go to the meetup.com/London AI Tech Talk and sign up. This is the best way to sort of get updated on the latest events that we have. Anandita is going to be speaking about different models, I think KNN and whatnot, on the 4th of March. So if you're around London or if you are free and want to join in the webinar, please do sign up on the meetup so that you don't miss out on when our latest events happen. Yeah. And if you're on the global side, go to the AI Camp website as well. And that's where we have the weekly talks as well as some courses for you. All right. Okay. Yeah. So the session is now sort of done. let me know if you have any questions, if you wanted any recommendations for what you like to learn in the future. Let us know. I think for the London side, we're gonna have some courses about Google Cloud Platform and its architecture in the coming months. So do keep posted for that. All right.
Hello, thanks David for the talk. And we are right on time, maybe like 1 minute left. If you have any questions, you can post in the chat window or in the Q&A session. All right, so seems like we are all good. Thanks again, everyone, for joining us today. We post some links for our next event online or in person in London Meetup Group. I hope to see you all again in the next event.
Okay, Vikas has one question. Will there be a Kaggle session on how to use the software? Okay. Yeah, I was wondering if other people like this as well. And if there's quite a lot of interest in this, we can always arrange a series of this. So I'm thinking, yeah, if it's quite popular, we might do a couple of sort of sessions where we can work through how to use the notebooks on Kaggle, and maybe a smaller group where we can sort of work through one by one on a face-to-face basis. And if people are really interested, we can really run our own competitions on Kaggle as well, where the AI camp participants can sort of see on the leaderboard and see who is better, which model is better, and we might run some prizes for that as well if there is sort of more and more interest on this.
Yeah, absolutely. I think that's actually a great idea. And David, you probably can lead a team and have a few people join together as a team to participate some of the competitions on the Kaggle. See if you guys can get some prize.
Yeah, that would be pretty fun as well.
I think for the one Facebook, they published one of the competition for $1 million for the deep fake detection, right?
Yeah, that's right.
Yeah, I think one of the speakers actually a few days ago in Seattle, our conference in Seattle, they mentioned about the Cago competition. That's actually his team involved, put up on that competition along with AWS, Amazon, Microsoft. So it's a very very large competition on Kaggle. The price is $1 million. So yeah, let's go try to get it.
Awesome. It is pretty high profile one. Yes.
Yeah.
So yeah. Let me just respond to Vikas. Is there a particular sort of part on a particular section on Kaggle that you wanted to know more about? Can always sort of drop us an email, or if we do post another webinar on Kaggle, we might sort of take into account to use your idea as a demonstration. Yeah.
All right, so I also put the AI Campus emails on the chat window. If you are interested in any new webinars or workshops on Kaggle, on any other machine learning AI related events or learnings you are interested, just shoot us an email and we will see, how to put it together and to get it get it delivered.
Awesome, Bill. Yes, that's a great idea.